So we've talked about alleles, we've talked about phenotype. Mutation? Come on, this is easy peasy. We know what a bloody mutation is.
Changing the DNA.
Changing what aspect of it?
Base pairs. Or the
Sequence.
yeah.
Base sequence. Okay, so changing the base sequence. Alright then. When we're talking about evolution and talking about humans affecting the evolution of other species, things evolve when there is a shift in the type and frequency of alleles in a population. So we're used to talking about evolution as, well, there's a mutation, and that mutation is beneficial in the environment that the particular species lives in, and because it's beneficial, those members of the species are more likely to survive, and so that mutation will spread throughout the population. Okay. Well, of course, any new mutation is a new allele. It's a new variation on a gene. If we, what would be a good example? You know, we've got 3 or 4 genes that control eye colour. Let's say we get a mutation that gives somebody pink eyes, right? A pink iris. Yeah. So now we've got green, brown, blue, that kind of weird grey blue colour that's not really grey and not really blue that some people have, and then we've got pink. Yeah. And let's say that pink eyes looks really attractive. Girls all want a boyfriend with pink eyes. Now I'm going to say, look at my fella. He's got pink eyes and he wears a onesie. Yeah. So the mutation become more prevalent in the population because it's being selected for. Yeah. So we're going to look today at how the frequency of alleles changes in a population. Okay. And it's got something to do with selection. So let's just recap on what natural selection is. How does natural selection work?
Variation.
Right.
Variation.
So we start off good with variation. The good thing I think about this unit, looking through it, is that we've already done most of it in some guise. So a lot of it is just revising things that we've already done. So we start off with variation. What else do we need for selection to happen?
Is it not too many offspring?
Yeah, good. Too many offspring. Come on, Jasmine.
I don't know.
You do. Think about, you know, Darwin's finches on their little islands with their different beak sizes. There's too many of them living there. What's going to happen to some of them?
Well, survival of the fittest. Like, some of them will compete.
Okay,
Kill
good.
that.
That's what I'm looking for. You said it. So, competition. What are we competing for?
Food.
Let's take
Shelter.
let's take beak size as an example. We're competing for food. So there's competition for food. What's going to happen to some of them, Jasmine?
Die.
They're going to die. If some die, then some
Survive.
survive. Good. Some die, some survive. What happens to these ones that survive?
Reproduce.
Reproduce. They reproduce, their offspring will exhibit.
Long beak.
Well, it depends what.
You said we was using the beak as the example.
The best type of beak.
All right, okay. So they'll exhibit the phenotype that was best suited to the environment. But within that best suited phenotype, there will be some
Variation.
variation. That goes back round. Okay.